Okay, so we're just going to continue on with our sandbars, okay? I just said we'd start a new video because there's quite a bit. So sandbar then, okay? Again, just like with our sand spit, sometimes a sandbar can be an extension of a sand spit. If you've got a small little bay area, okay, longshore drift comes along, it builds, and a sand spit can actually reach the whole way across the piece here, okay? And actually turns into what we call a sandbar. Now sometimes those sandbars leave a lagoon just behind them, alright, which again this will eventually fill up with sediment and become land. Alright, other sandbars form a little bit out off the coast, okay, again due to sand being dropped just off the coast in calm conditions. Alright, and again sometimes you can see these sandbars, alright, they're exposed at low tide. You can actually walk out onto them. Gold Rock Bay up in Freeport or up in Grand Bahama springs to mind, where there's a lot of sandbars. Alright, so sandbars is just a build up of sediment just off the coast. So you can see this is an example of one with a lagoon behind it, okay? So you can see it was a sand spit and then it actually went the whole way across. It reached the whole way across because if you can see up here, there was actual land on the other side. The water never got too deep or powerful. So this would have started out as a spit and then went the whole way across. And now you've got this big lagoon behind it, okay? And again, all it is longshore drift depositing for as long as it can over time. That's all it is. Okay, this next one, the next photo is looking in just in here, all right? So again, you can see again the actual size of these. Alright, this is the lagoon side, that's the ocean out there. You can see the sand spit going off into the distance. But we're talking huge marinas, huge hotels, big road systems and everything. Okay, so as soon as new land is made, naturally, people jump on and start building whatever we want. Okay, now we also talked about tombolos, and a tombolo is very cool. Alright, again, notice the same thing. Coast comes along, change in direction. Longshore drift's coming along here. There's a change in the direction of the coast. Deposition occurs here. Longshore drift continues every day and eventually builds up land out to a little island. Okay, so actually Lyford Key happened in exactly the same way. Okay, it was actually not connected to the mainland until deposition occurred, making a little walkway. Again, just like with sandbars, okay, our tombolos are sometimes not visible at high tide, only low tide. Alright, so this is a cool example here. So we had the mainland, I don't actually know where this is, and a little island just off it. And you've got this tombolo, which reaches all the way out. So you can see all the people out there walking on it. Alright, and again, another example here. Notice how the material is always kind of sand and small stone. Alright, now some tombolos, when the tide rises, this will be covered. And then the tide goes down and you can walk over it. And so on. Alright, so we got our tombolos. We're going to go back and finish Bunnet very briefly, and then we'll move on to Bahamian Landscapes, page 101 to 106. Alright, so Bunnet first, and then Bahamian Landscapes. Okay, just at the very bottom of page 148, in Bunnet, salt marshes. Okay, and then we're going to jump straight up onto 149. Okay, now, top of page 149, as you can see, and again, we've already defined the word salt marshes, okay? But what I want to do is just look at these. Mostly form behind sand spits or near where rivers join the ocean. Remember, as a river joins the ocean, it dumps lots of material, okay, that it's collected over the land. In behind sand spits and sandbars, the water is usually protected slightly from the waves, and it's usually shallower already. So I put some little steps. I put 1, 2, and 3 into the formation of a salt marsh, okay? So mud only settles to the bottom where water is almost motionless, so where it's very calm. Again, in behind sand spits and bars, or very close to the coast. That's step 1. Okay, so it accumulates in sheltered areas. Think about back to our diagrams for our sand spits, what happens in behind them. Number 2, grasses and seaweeds will grow in the mud. Very simple. Alright. Number 3, grasses cause more mud to be deposited, so as there's more plant life or vegetation growing, it slows down the water even more and catches more of this sediment. The level of the mud therefore is raised. Alright, Mudflats, as they're sometimes called, become salt marshes. So again, you could call it a mudflat, you could call it salt marshes. At low tide, as we see here, okay, at low tide, some of the land will be exposed. At high tide, some of it will be submerged. But again, there's one other ingredient to add in, and that's time. So over a long period of time, if this continues to happen, all of this here will eventually rise up above sea level. And once that happens, then you will see humans will go in and start to try and backfill it with rock and stone, then concrete, and then build on top of it. Okay, so that's what we're going to look at just down here, this idea of reclaiming land. So add that in there. As the level of the salt marsh is raised by the deposition of mud, so mud and sand and rock being deposited, okay, the entry of salt water is gradually restricted until it enters perhaps only once or twice a year. All right, so now what you actually have is we had kind of mudflats that were underwater most of the year, to now we have land which maybe twice a year the highest tide will flood it, and that's it. When this stage is reached, it then becomes possible to reclaim the salt marshes fairly easily by building embankments and digging drainage channels. All right, so all we do is drain the land fairly easy. We can pump water out, you can dig drainage channels, and then we can build embankments to stop any water getting in there. And then it's just time, let it dry out, let it solidify, okay, all that mud will compact down over time, we can compress it, and then we get solid land. All right, I should have said as well, the reason they're called salt marshes is because it's got a high salt concentration. All right, as it starts to become more and more land, there's more and more evaporation and salt left behind, so it can be quite salty. Alright, that's us finished with Bonnet. We're going to move on to Bahamian Landscapes, page 101. Alright, so on page 101 with Bonnet, or with Bahamian Landscapes, we're going to start looking at, we're going to go through the same kind of features again. We're going to look at Bahamian examples, and we're just going to look at sand dunes in particular now as well. Now I put down the Bonnet pages. Bonnet on page 150 in particular does sand dunes, but I feel that it's covered better here, it's got a better diagram and more relevant information, so we're just going to look at it from Bahamian Landscapes. Okay, so sand dunes, fairly common in the Bahamas, okay, north side of Paradise Island, so again along Cabbage Beach. Anybody has been to Cabbage Beach, you'll notice the quite dramatic sand dunes at the back of it. East coast of Eleuthera, so just some examples of where really good sand dunes occur. Okay, the beach area collects sand as a result of wave action, and at low tide this is dried and exposed to the wind. So what you have is a beach collects sand, so the waves come in, the constructive waves in particular come in, they deposit sand. Alright, at low tide, when the water has gone out, this sand is then dried in the sun and exposed to wind. Alright, we know how easy it is to blow sand around. The wind blows the finest sand up the beach, okay, away from the ocean, above the high tide level. So now what you have is you get this sand for half a day pretty much when it's exposed at low tide. It's been blown to the back of the beach where it builds up. Alright, so it builds up into a sand dune. At this point, sand tolerant plants, we've already done halophytic, okay, they live just above the high tide level and they'll trap all the sand. So it's a combination of things. You have this sand being blown up the beach, and you've got vegetation already there to trap the sand. And what happens is the sand will build up. Okay, so this is a massive sand dune along Long Island. Okay, some examples of vegetation which we'll look at shortly. Sea oats and spider lily, alright, are visible in the foreground. Now, note how the vegetation reaches down to the high water mark indicated by the seaweed. So again, we got our water level, okay, and you got your sand. Now, when this is exposed or not covered in water, it'll be blown up away from the sea because the winds come in off the sea. As the sand gets blown up here, it gets caught up in all this vegetation and starts to mound up higher and higher into our sand dunes. Also, as we said earlier, note the way all the seaweed is at a kind of similar level. So we can say for a fact that's where high tide is, okay? And you can see how the vegetation grows almost all the way down to the high tide level. It won't grow further down because that means it'll spend half its day underwater, which it probably doesn't like. Okay, so Just going to stop there. We're going to continue on to page 102 in the next video.